So now let's start with the Pandas library. So in this Pandas library, we have to break down this into three sessions, phase one, phase two, and phase three. But we will be covering these eight topics in a lot of detail. Okay, so Pandas library, what is its use, how it is the most important library for the actuaries and finance people. That is why I am going to spend a lot of my time on this library, and I will be covering a lot of features, a lot of functions, a lot of ifs and buts. No matter what, we are going to cover this library in detail. And I can assure you, if you become comfortable with this library, no one can stop you from becoming the best Python programmer in the field of actuarial science or any finance field, to be honest. Okay, so with this, let's begin. Okay, so yeah, so just I have written down few small notes. So what exactly is this Pandas library all about? So it is majorly used for the data analysis purpose. Okay, and in this complete three phases of this Pandas videos that I will be creating now, we will cover about series, data frames, and missing data. These three we will cover in today's session, followed by group by, merging, joining, concatenation, operations, then how to deal with your Excel file and CSV. Basically, any type of data, how to deal with that. Okay. So now let's start with the series. So basically, in this session, we will cover about series, data frame, and missing data. So series, data frames, and missing data. That is something we will cover. Okay, so now the question is that what exactly is this series? So it is like similar to the NumPy that we have done in our previous session, and we will understand what exactly are the differences. The point is that in case of a NumPy, it just handles the numerical data, but in case of a series, we can handle numerical as well as non-numerical data too. And in case of series, we can assign the index name, index values as well. What am I saying? Let's start coding and understand it in a better detail. Before starting any library, you have to import that library. That is something clear, right? So let's say if I am working on NumPy library, I will type import NumPy as NP. Similarly, if I have to start working on the Pandas library, I have to type import Pandas as PD. Make sense? Shift enter. Super simple. And one more point. Suppose this code does not work in your case. It means that the library has not been installed in your system. And I have covered in my, I think, second lecture about the modules that if any specific library is not installed in your system, then you can install by typing CMD over here. Do not go to the Anaconda prompt. Go to the, oh, sorry, do not go to the command prompt. Go to the Anaconda prompt. Okay, and over here the location will comes up automatically, and then you will type conda install and the name of the library, that is Pandas, and press enter. In my case it is already installed, so I will not press enter, but if in your case also it is not installed, then you can type this. But by default, with the Anaconda that we have installed, these libraries come along with that, so you don't have to worry about it. Okay, so yeah, we have imported the both of the libraries, that is Pandas, which is super important for this session, and import NumPy. Let's create some blank cells, more plus 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 plus. Let's start working on that now. Okay, so let's say I will create a data in 3 4 different ways, in terms of a list, in terms of array, in terms of dictionary. Let's create it. I am creating a parameter named as labels, and I'm saving it in a list way. I will type p q R, comma S. S. Okay, simple and sorted stuff. I will create one more list. Let's call it a new list, and I will save it like 50, 60, 70, 80. Okay, and let's create one array. So let's call it new array. So I have to use numpy dot array, and within that I will pass on a list. Let's say 20, uh, 30, 40, 50. And let's create one dictionary as well. Let's call it new dict. So we know that in case of a dictionary, we have to pass the key and their corresponding value. So let's say my favorite fruit is apple. The cost of apple is 100. The quantity that I bought was, let's say, 1 kg. Okay, 1 kg. These are the four parameters that I have created. Now let's create a series. Okay, let's create a series. So what I will type now, pd dot, because I have imported the panda, so I will type pd dot. Now press enter. When I press enter, you see Tons and tons of features are there for you guys, and we will cover a lot of them which are highly relevant for actuaries. We are not going to learn something which is not useful at all for the actuarial and finance people and just keep on learning from the another domain perspective. That is not the objective. That is why you have enrolled in this Python for actuaries and finance course. Okay, so pd dot, I will type series. Okay, then your brackets, shift tab. What I have to pass on, I have to give the data, index, and so on. Let's say I will only pass the data. The data is, let's say I will pass this new array. Okay, new array. Now you see that for me the series has been created. First of all, what is this new array? New array was 20, 30, 40, 50. New array 20, 30, 40, 50, and it has given me by default the indexation for them, that is 0, 1, 2, 3. That is what I said over there. It can be indexed with the label, meaning we will have a serial number along with that also. But you have the functionality within the series where you can define your own index values. Index, so over here when I say the index, it means the name of the row heading. The name of the row heading. This is row, this is column. Makes sense? Super sorted. Let's say if I type pt dot series, my data is this new array, and my index means this row heading. The index is, let's say, labels, which is, then it will come like pqrs. Index will be labels. And now you see pqrs is my row headings, and these are their corresponding values. Okay, now you know what, you can even reverse it as well. Let's say if I'll type pd dot series, my data is this labels, and my index is this new array. And you can see now these are your index headings, row headings I will say, and these are their corresponding values, pqrs. But what about the dictionary? So we have created this new dictionary where we have their key and their corresponding value, key value, key value. Let's try to do this. New dict. So by default it is going to pick your keys as your row heading, and these are their corresponding values. Sorry, yeah, so these are their keys and these are their corresponding values. So that is what you can do using the dictionary. Okay, so we have learned how to create the dictionary using, we have learned how to create the series using dictionary, numpy, and the list. Now let's move on and understand with the help of one example. Let's create a series from scratch. So let's say I will type nominal GDP of the country. I will type pd dot series, and now data, I have to pass on data, right? Let's say I will pass on data manually by myself. The data is, let's say, 25 trillion, 15 trillion, 5 trillion, and 3.2 trillion. Okay, comma, I have to assign the index. Index means these row headings. So let's say this 25 trillion is of USA, 15 trillion is of China, 5 trillion is of India, and 3.2 trillion is of Germany. Okay, just normal, super simple example. Now if I check the value of my nominal GDP, you can see that. Okay, and it is a float data type, which we all know, right? 3.2, these are all considered as decimal, so it is float, not an integer. So nominal GDP. Now let's say I will create on a similar basis the real GDP as well. Let's call it real GDP. I mean, obviously the real will be less than the nominal GDP if there is an inflation in the economy. Super simple economics concept. Okay, so data is now let's say 20, 10, 4, 2.2. Same countries. Okay, so now if I check my real GDP, that is how it looks like. So I have the nominal GDP of the country, the real GDP of the country. Now if I want to find the inflation, that is just what? Nominal nominal minus real GDP. Makes sense? And that's, you get your answer. That currently the inflation rate in USA is this, so on. So that is all about the series. Let's cover one more feature within this series. So the nominal GDP is this. I can apply the indexation over here as well. What is the row heading? These are the row headings. So I will pass on, let's say, India. I get the answer for India, that is $5 trillion. Super sorted. That is how you can do the indexing of a series. Okay. Indexing, what exactly is the meaning of indexing? That is what we are doing for so long in case of a strings lecture, list lecture, all of the other data types lecture. Then in the NumPy as well, we covered that. So what exactly is this indexing? Indexing means that you are trying to find a specific value or values using different methods, right? In this series, I am trying to find the value of India nominal GDP. That is what I did over there. Nothing else. Pure common sense. Okay, super sorted. So we have covered about the concept of series. Now let's move on and talk about data frames. This is the most important thing, and we will be learning about a lot of features in this. So in this data frames, we will understand how to deal with the NumPy arrays, and then how to create the data frame, indexing, slicing, how to deal with row, columns, both of them, filtering, indexing of the, how to reset, set and multiple index, a lot of features that we will be covering right now. Okay, so without wasting even a minute, let's begin. So we have imported the NumPy library over there at the top. Okay. Now let's say I will type now. I will create the data frame. I will type pd dot data frame. Okay. Okay. Let's say before that I will create one data. X is equal to NumPy dot random dot rand n, normal distribution, right? And I need 4 rows and 3 columns. And if I check the value of X, it is 4 rows and 3 columns. I can see the data, right? Let's create some more blank cells over here. Okay. 4 rows, 3 columns, and this entire data is following the normal distribution. Now let's pass on this data within the data frame. See, the major difference between the series and a data frame is that in case of a series, we have only one single column. These are their corresponding row headings. Okay, these are not column values. These are the column values. But in case of a data frame, we have more than one column, and it will become like a matrix, which is basically looks like your Excel. What am I saying? Let's take a look. So this is the value for an X, right? We have 4 rows and 3 columns, which are following the normal distribution. Now let's create the data frame. Let's call it df. pd dot. Now I will type data frame. Data frame. Shift tab. Let's see what it is saying. That you have to give the data, then you have to assign their index, basically row headings, then your column headings. Okay. By default, otherwise it will take 0, 1, 2, 3. For index, it will take 0, 1, 2, 3. Simple sorted stuff. So what is my data? My data is X that I have created over there. Okay. This is my data. Now let's create the index as well. So index is, so you can see it is row heading. So we have 4 rows. So I will assign 4 rows. W, X, Y, Z. These are my row headings. I can assign the column headings as well. So how many columns do I have? 1, 2, 3. There are 3 columns. I will assign, let's say A, B, and C. Now, if I take a look at my data frame, that's how it looks like. You see, if there is only one column, we call it a series. If there are more than one columns, it become exactly, you call it a matrix, or you call it like the replica of Excel. That is what your data frame is. And now if you see carefully, this is your data, right? 1.83, so on up to minus 0.34. The entire exact same data that we have pasted. Index, which means the heading over headings of the rows, WXYZ. You can see WXYZ. Columns heading ABC. If you don't assign any value for index, by default it will pick 0, 1, 2, 3. Same concept for columns. If you don't assign the any names, so by default the Python pandas is going to pick 0, 1, 2. Super simple stuff. Okay, up to this point, I hope it is clear to all of you guys. So now we have covered in this data frame section how to create the data frame. So we need the data, we need column headings, we need in rows headings. Super simple stuff. Okay, let's move on, and then let's start with the concept of indexing and slicing. In that we will learn how to deal with columns, how to deal with the rows. Okay, so I will make the heading indexing and slicing. So okay, so now my data frame is this. Let's say if I want to see the values only for this W, it gives me an error that you cannot do that. You see, This is star. Star means that it is currently running. Now there is a number which means that the run has been completed, but I can see that it gives me an error, that key error w, that w does not exist, whereas w is there. I can see that. If you remember, in case of a series, we just give the name of the row heading, that is India, and we get our value. That is the main point to understand over here, that in case of the data frame, that's not how it works. So how does that it works? Now let's say, first of all, I will talk about the columns, how to bring the columns. So if you see over here, first of all, we will learn how to deal with columns, single column, multiple columns, how to add the column, delete it, and how to make it permanent. Let's understand this in detail now. So this is my data frame, right? If I want to see the values for only column A, what I will type df column A, and you get the answer. Why it does not work? Because in case of the rows, there is different concept that we will learn in just 5-6 minutes. But in case of the columns, that's how it works. You give the heading of the column, you get your values. What is the value for a column? And you get all these values. That is for the single column. If you want to see the values for more than one column, let's say you want to see the values for column A and column C, how to do that? Simple stuff. Within this, you will create one more list. Call it A and comma C. You want to see the values for A and C. Over here, you just wanted the value for A, so you are not passing on any another list. But in that, you are passing it. Okay. So df of A, df. Now within that, A and C. Okay. Now trigger this, you see the values for A and C. So you have learned how to index the single column, how to index multiple columns, which means more than one. You can keep on adding as much as you want. Let's see if I type B over there again, A, C, B. Basically, the way I am putting these values, the way I am getting my answer. Super simple stuff. Now, again, this is my data frame, right? Let's say now how to add one more column. How to add one more column. So I will type df, create one more column. Let's call it D. And I have to pass on 4 values. So I will type, let's say, Lisa, John, Randy, and the Undertaker. Right now, if I check the value for df, you can see A, B, C, D. These are their corresponding values, right? Not only this, I can add the mathematical columns as well. Let's say if I want to create one more column, let's call it column E, and I will pass on that I want the summation of A and B. So I will type what? df of A plus df of B. Simple. And always remember, the Python is case sensitive. If I type this, it will not work. Why? Because it is capital B. Okay. So now if I check the value for df, you can see A, B, C, D, E, where E is the summation of A and B. 1.8 plus 0.39 is equal to 2.23 and something. Simple stuff. I can apply more mathematical calculations. Let's say if I create one more column, let's call it F. And I want df of A, right, plus df of B. And I want it together to be multiplied by 100 into 100. So now if I check the value of df, you can see. Let's create some more. So what is this F? Basically multiplication of E into 100. So you can see 2.23 is 223 and something, so on. Okay, so we have learned now how to add the column as well. Now the major topic is how to delete the column. Okay, how to delete. But let's say before that, I will tell you how to overwrite. Let's say this is the value for F. Okay, I want this value to be A minus B. So by mistake, I did this thing. I want to overwrite these values. So what I will do, same thing. Just type your column name and then just edit it. So df of A minus df of B. So you can see the values have already been overwritten. Okay, so we have learned about how to pick the single column, multiple columns, add the column, overwrite the column. Now let's understand about how to delete the columns. So I will type df dot drop. Okay, and within that I will type F. And now this, it gives me, let's say what will happen. It has given me an error that it has not found in the axis. Okay, so what does this axis is all about? Let's go over there, press shift tab, and you see by default the axis is 0. So axis is 0 means that it is talking about the rows. So what is going on? So Python is, so when I type this code, Python is assuming that this f is the heading name of a row, whereas it is not the case. WXYZ. That is why it is saying that f does not found in axis, because by default the axis is 0. When axis is 0, it means that you are talking about the rows, but I am talking about the column. So put comma axis is equal to 1. Now if I trigger this, you can see the f gone. We will cover about rows later. Right now we are talking about the columns. That is why I am focusing over there. So whenever you want to delete any column, you have to give the axis value as 1, whereas by default the value for axis is 0. Okay, the by default value for axis is 0, which indicates rows. So it is clear. But now if I check the values of my data frame, f is again there. It means, how can I make it permanent? How can I make it permanent? There is one way. Put again df dot drop. I want to drop column f, right? Simple stuff. Where the axis, where the axis is 1, and I will type in place is equal to true. Now if I trigger this, and now if I check my data frame, you can see that f is gone. So what is this in place? Let's go over there and press shift tab. You can see in place, by default it is false. So in place is majorly used when you want to make something permanent. So by default it is false, so that let's say, if you are working on something and you are not sure whether you want to save it as a final output or not, that is why it has given you the functionality that by default in place is false. Once you are sure that okay, this is the final data frame that you are creating, you can just convert it, then you can basically make it permanent by typing the value in place is equal to true. Okay, that is what it means. That is what it is all about. And this f, we call it label. So you can just type, labels is equal to like this as well. It is all up to you. It does not work right now because we have already triggered the f. So that is what happened. Let's say even in this example, I want to drop column D and E. So I will pass on as a list. I will type column D and column E. I have to put comma over there. Shit. Now, again, it has given me an error. Let's take a look what just happened over here. Column D, column E, df dot drop, and so it is saying that unterminated string literal. What we can do is, first of all, let's type df over there. Let's remove this. Let's create some more cells. So this is the final df that we have right now. Sorted. Now let's say I want to drop column D and column E. So I will type df, right? Drop. Put this. And I am passing on D and column E that I wanted to drop. Comma. Axis is equal to 1. Comma. In place is equal to true. And do this. Now if I check my data frame, A, B, C, right? It has gone. Column D and column E gone. Okay. So in this section, we have learned, so basically we have covered up to this point. Single column, multiple columns, how to index them, how to add, delete, and make it permanent using the in place. Same concept for, we will learn about the rows, but there is a concept of lock and iLock method. Let's understand about that as well. So let's begin with dealing with rows. Okay. So I will type now. So let's take a look. This is my data frame. Make sense? Now there are two methods. That is lock method. Let's call it location name. And there is iLock method. That is the index location number. iLoc, name suggests index location, loc, location. So what is this all about? Let's understand. Let's first of all take a look at the loc method. df.loc, loc, put your scale brackets. Now if I want to see the values for x, I will type x over there and I can see the rows. Okay, so now you see the major difference. If I want to bring the columns only, I will just type like this df.loc and put b over there, let's say, and I can get the b's. But if I type x over there, I did not get my answer. So I have to use df.loc. So when I put loc, now it is going to be in the row side and it has given me the answer. loc, so for x, so I am now grabbing the rows value df.loc x and I get my answer. If I want to grab more than one rows, simple stuff, df.loc, put 2 times list, and let's say I am interested in this w and y, so I will type w comma y and I get this as my answer. Super duper simple stuff. Make sense? Now let's move on. So we have learned about location. Let me talk about index location, that is iLoc. Okay, df.iloc. Let's say now if again this loc and iLoc, both of them are used for grabbing the initially for grabbing the rows. So now if I type x over there again, x, now it gives me an error. So that is what I said over there. When you are using the loc method, you have to give the name of that index heading, that is x, that is y. But when you are using the iLoc method, you have to give the index location number. So we know that by default, this is 0, this is 1, this is 2, and this is 3. This is known as the index location. So it means if I want to grab the value for x, I will type 1. Let's come back over here. iLoc, press, type 1 and trigger this. You get the values for your x heading. These are their corresponding values. Let's take a look at again. I want to bring the values for w and z using the iLoc method. I will type df.iloc, bracket start, and within this bracket, I will type what? 0, 1, 2, 3, which means 0, 3, right? So I will type 0, 3, and you see w and z. So list within a list. Okay, right now it is about rows. So using this loc and iLoc method, not only I can bring the rows, I can also bring rows and columns together as well. That is what we will cover in just a couple of minutes. But right now about the rows, you are pretty much clear that if you want to grab just one single row, you can just give the name of the index location. If you want to grab more than one rows, just put it one more time within a list over here within that. Same thing with the loc method. You can put within a list after this scare bracket. Super simple stuff. Let's go to the topics that we want to cover. So we have covered about the loc method, iLoc method. Okay, we have covered about how to do that in case of a single rows and the multiple rows. Now the most important concept, how to grab the specific rows and columns together. Because right now we have learned about how to deal with columns separately, deal with rows separately. Now let's deal with rows and columns together. Okay, let's take a look now. So this is my data frame. Make sense? A, B, C, W, X, Y, Z. So let's say now, understand first of all, I am interested in this W row and B column, which means this value. I am interested in this value. How can I grab this value? Again, two methods, loc and iLoc. These are the two methods that is available. I will type df.loc, bracket. Okay. Always remember that you have to pass on rows, columns. So what am I saying? Let's take a look. I am interested in loc. It means I have to give the name of heading. That is W. So I will type, oh, that is Y. Sorry. Y is the row heading. B is the column heading. So Y, B. Okay. Now if I trigger this, you get the value 0.067. But now you may be confused right now that over here also I put the comma But when I put the comma over there, let's take this example. When I put the comma over there, I get two rows, W and Y. I did not get this Y as a column. Whereas in this case, you put the comma and then value. Now it is giving me the column heading. What is going on? But now let's take a look at it very carefully. This is within a list. It means that technically it is the one single element within this square bracket. Okay, that is the magic. But over here, I have not put it into a list right now. So by default, this is the row and this is the column for me. Okay, rows, comma, columns. But if I will, put more rows, I need more than one rows, I need more than one columns, then I will put these values within a list. How to do that? Let's take a look. What am I saying is, I will put df.loc, bracket start. I am interested in W row and Z row. So I will put it within a list, right? W, comma, Z. That is what we did over there as well. If you see, that is my value. I will put comma. I am interested in column A and column C. So put list column A, comma, column C. And you get your answer. That is the magic of this lock method. And same thing with the iLock method that we will do right now. Let's understand what just happened. Y, comma, B. You put this comma, so by default it is going to pick the next value as a column heading. Okay, but in this case, because we are interested in the multiple rows and columns, so this comma is this comma, and before this comma I have this one value that is for my rows. I need W and Z. That is why I pass it on as a list. After this comma, I have to put the values for columns and I pass it on as a list, A and C. Same thing, I can do it using the iLock method as well. So let's take a look how to do that using the iLock method. I will type, let's say df.iloc. Let's say I am interested in this value, 0.39 something. So what is the row number? That is 0. I will type 0 over there. What is the column number? Again 0. I will put 0 over there and I get my answer, 0.39 something. Super simple. Now let's say I am interested in the W and Z. Same thing. I am interested in W and Z and A and C. How to do that using iLock method? I will type df.iloc. Okay. I am interested in the W and Z, which means 0, 1, 2, 3. 0 and 3 number of column. So I will put again list 0, 3. Come out of the list, put comma. Now values for heading, values for column. I am interested in the column A and column C, which is 0 and 2. So I will put 0, 2. And that is my answer. So it is all up to you. You want to use the location in which LOC, in which you have to use the name of heading. You can use ILOC, in which you have to use the index number of that heading, whether it is of rows or of columns. Super simple and very, very important stuff when you are, grabbing the precise specific data. Okay, that is what it is all about. So if we come back to this, so we have learned about this entire section. Now let's talk about how to filter your data frame on a specific condition, one single condition, multiple conditions, how to do that in case of numbers, and how to deal with that in case of the text values. Let's understand that in detail. Create more headings. Okay, now this is my data frame, right? I want to see all of the values in this data frame where the values are greater than 0. Put df within that where df is greater than 0. You can see the values. NaN, as we discussed earlier, I think as well. NaN means not a number. NaN, not a number. The point is that, Pandas, Python is trying to put this NaN just for the simplicity purpose that there are no values assigned to them, which makes sense. You see df greater than 0 and I can see that this entire 2 rows have values less than 0 because they are negative. That is why it has not given me any value for them. So it means when you apply this, it applies the filter on the entire data frame. Entire data frame. Is there a way through which, let's say, I am interested in the values where the values for column A has to be greater than 0? Or let's say I am interested in the column A where the values for column, I am interested in the entire data frame where the values for column A is greater than 1, which is this one. So basically I should get this as my answer. How to do that? I will type df. Within that, I am interested in df of A with the values greater than 1. And if I trigger this, you can see. So I have applied the condition that in case of A, let's create just for your visibility purpose. This is my data frame. I am saying that I am applying the filter where the values for column A has to be greater than 1, which is only this case. So I can get the entire answer. But let's say if I am only interested in the column A, so that is again fine. I will put B over there. This is my answer. What am I saying is, now if I trigger this, technically this is again a data frame. I can, let's say, save it over here. Y is equal to this, right? And the value for my Y is this. This is a data frame, right? And if I want to grab the column B, I can just type B over here and I can get my answer. And that is what I did over there. That if this is my data frame, okay, if this is my, delete this. Yeah, this is my data frame. I can put B over there again. And this is my answer. Super simple stuff. Try to understand one more time. I will put this is my data frame. Let's cut this. Yeah, this is my data frame. Now I am saying that I want the values where the values for column A has to be greater than 1, but I am interested in column A and column C. Super simple. df, this is your data frame. Put your condition. I want the where the values for column A has to be greater than 1. But I am interested in, come out of this, I am interested in column A and column C. Put your indexation over there. Super simple stuff. Column A, comma, column C. And you get your answer. Same thing, because this is in itself a data frame. Again, this entire line is in itself a data frame. You can save it on, let's say, in any other variable. Y is equal to this. This is your data frame, Y. Super simple stuff. You are creating the data frames out of data frame. That is what it is all about. Okay, let's take a look at some more examples. This is my data frame. I am interested in values where, let's say, let's try to, so this is all about the columns. Now let's try to take a look at from the rows perspective. Right now, just a simple condition. I am saying that where the values for column A this time, okay, now this time let's take less than 1. I can get this as my answer. Okay, so W, Y, and Z, these are 3 values which are less than 1. But I am interested in, instead of columns this time, I am interested in rows, that is Y and Z. So it means I have to use whether the loc method or iloc method, right? I will type, let's say, LOC, and I am interested in this Y and Z. I will pass on Y, comma, Z, and I get this as my answer. Pure simple logic. This is in itself a data frame. That is why I type this, and then after that I apply loc condition or iloc condition. Again, it is your choice, right? Let's take one more example, which is a little bit more complex, in which I will apply, right now I have applied the conditions for only rows. Let's bring rows and columns, both of them together. Okay, this is my data frame. First of all, I will apply my condition, single condition, where I am saying values for A is less than 1, right? I am interested in, I will put loc W and Z only. I will type W, comma, Z. And for column, I am interested in column A and column C. And this is my answer. Super simple stuff. No rocket science. Super duper simple stuff, right? So we have learned about filtering based on numbers. We have learned how to do that in case of a single, okay, single conditions we have learned right now. Filtering, because we have just applied one condition, right? That is where the value for column A, whether it is less than 1 or greater than 1, we just applied one single condition. But what will happen if I apply more than one condition? Let's say where the values for column A has to be less than 1 and value for column B has to be greater than 0. Or maybe I will, instead of and, I will type instead of or. How to do these two things also? Let's take a look. So this is my data frame, right? Come back over here. Now see carefully. First of all, let's apply two conditions. I will type df, put your square brackets. Now within this square bracket, I will put my entire condition. Make sense? Now I will say df where a, okay, df where a will be less than 1. Okay, this is my first condition. I will put it in a bracket, let's say this small bracket. Okay, then I will put and means that there is one more condition and I am applying and means that both of them have to be true. Okay, I apply one more condition, df where value for column b has to be greater than 0. I will put it again in a bracket. Okay, just remove this space, come back over here, just remove this space. Okay, so value for a has to be less than 1, which is in case of w, y and z, and value for b has to be greater than 0. So if I trigger this, you can see. So technically when I applied the a less than 1, so I should get w, y and z. But it is saying in case of w, y and z, the value for b has to be greater than 0, which is only in this case. Because for y and z, the value for b is less than 0. So we have applied the AND condition, which means both of them have to be true. That is how I get my answer. But instead of AND, is there a way through which I can apply the OR condition? Yes, there is. So copy this, paste this. Instead of typing AND over here, you can just type this. Okay, this symbol. This is again in your laptop. So in your laptop where there is a backslash, if you see carefully, so if you press shift backslash, this button is over there. Okay, so you can just apply this, and if I press enter, I can get the basically over here now I get the entire answer, because we are using the OR condition technically where a is less than 1. That is going on in case of w, y and z. So definitely I will get w, y, z as my answer. Now it is saying that or b is greater than 0. So if you see carefully, the x is greater than 0 for b. So it means I will get this row as my answer as well. So technically that is why I am getting the entire answer. There is no other logic. Okay, then after that you will again apply your indexing and slicing that we have done so far. Let's say if I am interested in only column A and column C, copy this, paste this, and I will put column, I'm interested in column B and C, right? I will put list within a list, column B, comma, column C, and I get this as my answer. Or if you want to use lock method, you can pick both rows and columns together, rows lock method or iLook method. Okay, simple stuff, right? So we have learned about how to do the filtering in case of numbers, single condition, multiple conditions, then grabbing single value, multiple values. How to do filtering based on values. Let's take a look. This is my data frame. Make sense? Let's remove this right now. Let's create another data frame. I think we have done so much with this one. Let's create the variable that is x. I am saying numpy.random.rand n normal distribution, and I need 4 rows and 3 columns. And if I check x, 4 rows, 3 columns. Let's create a data frame, call it a df1. I will put pd.data frame, and my data is x, and my index is. So see now, let's do some creativity. So earlier we did this, like w is your heading, x is your heading, y is your heading, z is your heading, right? Instead of typing this, what you can do, you can just simply write everything as a w, x, y, z, put dot split. Now what is this nonsense thing? If you remember our string session, let me revise you something. Let's say if I am creating a string, y is equal to w, x, y, z. Okay, so this is a string. We all know that, right? Type of y is string. I can use the function by the name split, if you remember. And if I don't put any value within that, so by default, it is going to convert it into a list, and the bifurcation will be based on the spaces, you can see. So technically we were typing this thing so far, that is w x y z. That is what we were doing, right? Same thing. This is the answer. But instead of typing this, what am I doing is this stuff, wxyz dot split. So just I think I'm trying to make it complex, but that is fine. wxyz dot split. Okay, so this is my index. Put now columns. Columns is equal to, now you can put it manually if you want, or you can use the same concept. Let's say three columns, right? So I will put A, B, C, or you can just using this method A, B, C dot split, and by default it is going to pick the space and split it into a list. Now it says incomplete output. Why it is saying? Because I have to close my bracket over there. That is for this. Shift enter. There you go. df1. So this is my new data frame with the rows and columns. Now let's say I add one more column by the name, let's call it regulations. And I have to pass on four values, right? Let's say the first value is Indian accounting standard. Let's put it United States generally accepted accounting principles, and I will put let's say solvency 2, and I will put again, let's say Indian accounting standard. So now if I check my, oh my god, this is in df. I have to put df1 over there, right? Because I am working on data frame 1. Let's trigger this again. So now if I check my data frame 1, I can see that one more column has been added by the name regulations. So now if I want to grab the values only for Indian accounting standards, super simple that we are doing so far. df1 within this bracket, now you put your condition, that is df1 of the regulations column I am interested in, where the value is equivalent to INDAS, and I get my answer. Always remember that I have covered earlier as well. If you use single equal to, it means you are assigning. You put double equal to, it means you are checking the equality. Super simple stuff, right? So we have learned how to do that to grab the single values, single condition, that is IND-AS. What if am I interested in, let's say IND-AS and US GAAP, or let's say I am interested in the US GAAP and solvency 2 as my answer. So if I use the same concept, copy this, paste it, that instead of typing this IND-AS, within that I will pass on list as US GAAP, okay, comma, solvency 2. Now it gives me an error that you cannot work it that way. Length must match to compare for 2, right? So now it is not working. How to do that? Let's understand now. I have to create one variable. Let's say I will create UK US regulation. This is the name of parameter, and I am assigning within that my US GAAP and solvency 2. Make sure that the naming convention has to be precisely same, because Python is case sensitive. Okay, now let's put this condition again. df1, within that I am putting df1 of the regulations. Pretty simple. I will come out of this. Over here, I will put dot is in UK US regulation and put your answer. And that's how you can get your answer. So what just happened? Let's try to understand. I am applying the one text-based condition. I am using IND-AS. I am interested in more than one condition. I tried this same concept, but it did not work. That is where this is in method comes in. That this is the filtering in which this is the place where within that I am applying this condition. I am saying that within this regulation column, I am interested is in this UK US regulations, which is basically US GAAP and solvency 2. Basically, you can put on as many conditions as you want, and you get your answer. Okay, so that is how you can do that. Sorted. Now if I make it a little bit more complex, so right now I just applied one condition, right, which is for the regulation. Let's say now I want to apply one more condition where the value for column A has to be greater than 1. So it means I should get only this as my answer. Make sense? value for column A has to be greater than 1. So let's pick this, copy, paste it, and put this entire one condition in one bracket over here. Put and put your another condition within this bracket, that is df of column A has to be greater than 1. And you see, that is your answer. Everything is simple, sorted. Just pure common sense, nothing else. Okay. So we have covered about, I know it's a bit long lecture, but believe me, it's worth it. So we have covered about this thing as well. Done with this. Now last topic for today, that is index knowledge. How to reset set multiple index. Not for today, but for this section. Then we have to cover about how to deal with missing values. It will have just 2 functions I want to cover. It will not take that much time. But try to watch this entire video in just one single sitting. It will definitely be very useful. So I am now talking about the index knowledge. Make a heading. What is my data frame? That's how it looks like. Okay. I want to, so see, by default the index is wxyz. I can reset my index. Now if I trigger this, it has reset my index from wxyz to 0123. But if I check my df again, it is back there. Why? Because I have to use in place condition. Okay, in place is equal to true, then only it will make it permanent. You see, by default in place is false. Make sense? So this is my data frame. Now let's say I am creating, let's not create the column. Let's create a column. Let's say I'm creating a column by the name countries. Okay. The countries are India, USA, UK, and India. Right? Because this 2 of India, this is of US, this is of UK. UK, or I should use European Union to be honest, to be precise, I guess. Right? So now this is my data frame and I want to assign this countries as my index. So I want to set this as my index. We have learned about how to reset the index. Let's understand how to set the index. I will type df dot set index. So what is the index that I want to assign? I want to assign countries as my index. And I want to make it permanent as well, please, this time. So now if I check my df, you see this is my index, countries, and these are their corresponding ABC regulation. Understand? There is one more concept I want to cover, that is multiple index, or we call it multi-index. Basically index 1, index 2, then you have their corresponding values, more than one index that you want to use. So the topic name is multi-index. So let's say I am creating one outer index, that is India. Let's copy this, comma India, comma India, comma India, comma USA. Let's put USA 4 times, comma USA, comma USA, comma USA. 4 times India, 4 times USA. I am creating now one more index, that is inner. Right now it is not index, I am just creating a list. Inner. Then I have to assign their corresponding values. Let's say 1, 2, 3, 4, 1, 2, 3, 4. Okay, super simple stuff. Let's zip them together. When you use the zip function, it basically converts it into a list which contains tuples. If you remember the zip function that we have covered in our previous session, when you were talking about the enumerate, zip, list comprehension, I hope you know about that session that we have covered earlier. Let's do that. I'm creating one more parameter. Let's call it my tuple. I am using the zip. Zip I am applying on outer and inner, and I have to typecast it into a list. So now if I check my tuple, that's how it looks like. Super simple stuff. Okay, so now I convert it into a multi-index. So I will type, let's say, multi_index as the name of my parameter, pd dot multi-index dot. So now, it will ask me that from which thing you have created your index, multiple index. I created it using the tuples, right? So from tuples. We'll type more from tuples. Then put your value, that is my tuple that I have created. So multiple index has been created now. It may look super duper similar to you, but now let's create the data frame. Then you will make able to understand. PD dot data frame, simple thing. My data is, let's say, numpy dot random dot rand n. I need now 8 rows and 2 columns. These are 8 rows, 4 rows for India, 4 rows for USA, and I am now creating 2 columns. Let's say where I will give the values for those columns, which will be this data. So 8 rows, 2 columns, and my index is now this multi-index, this that I have created. And my column headings are A and B, A comma B. So now if you check your data frame, you see this is the outer index, this is the inner index. Let's call it, let's say, north, south, east, west, 4 directions. So north, south, east, west, just understand it in that way. And these are their corresponding values for column A and column B. Make sense? Now if you want to apply the indexing, let's say I will type df.loc. loc means that now location in which I have to check the values for India. So I will just type India and I can see the values for India. I am interested only in 1. So I will type .loc again and put 1. You see the values for A. Oh, values for 1. Right? Makes sense? If you see carefully, over here we have the heading for these even rows as well. Right? These are index. So we have this index name, that is countries. But over here we don't have any index name either for this or for this. Let's assign it. First of all, I can see it from my naked eyes that there is no heading. But how to check that using the Python code? So this is my data frame, and I will type df.index.names. You see none, which means there is no value over there. None is a data type, if you remember. So I can assign the values df.index.names, and the names will be country and direction zone. Right? This is the country and these are the direction zones, let's say. So now if you check your data frame, the headings has been assigned to the index as well. This is the country and this is the direction zone. Okay. So now, let's say there is one more concept, that is the cross section. What is this cross section? Understand it. We know how to grab the values for USA and for this specific, let's say this direction zone 2 that we did for India as well over there. Where it is? Yeah, over here. Now if I ask you that I want to see the values for both of the countries, but for direction zone 2. Basically for India I need 2, for USA I need 2. There is a method known as cross section, or you call it access. Let's take a look how to do that. I will type df.access. Within that, let's take a look what it is saying. You have to give the index label first of all for your key. So for key, index label. So what is the name? Let's say I am interested in this 2. So I will type 2 over there, comma. What it is saying? Put now the axis. So by default axis is 0, which is so it means that I don't have to type axis is equal to 0 again. By default it is there. Even though you can put it, it doesn't make sense, to be honest, but you can type it, nothing will happen, because I am right now extracting the values from my index as well, from my rows. Okay, so key, then you have to assign the level, that from which index label you are interested in. So I am interested in this direction zone, right? So I will type level is equal to direction zone. Makes sense? So you see, for India and USA, the direction zone, which is 2, you can see the values 016095, 016095. For USA, 967400. You can see that. So that is the logic of cross section. Okay. I know the session is getting pretty much big right now. You are exhausted. So am I. So we have covered this data frames. Just come to this last topic for today, that is missing data. I will just take 2-3 more minutes, not more than that. Let's come to the last section. So we will talk about the two functions, that is drop NA and fill NA. So let's create a dictionary, my underscore dict. Curly brackets, I have to assign the key. Let's say key is India, and now put their corresponding values. Let's say 2030.np.nan. This nan is not a null number. You can even create that as well. That is why I type numpy.nan. This, put another one, let's say for USA, the values are 10 comma np.nan, np.nan. So basically, you know why I'm typing this nan? Because now I have to teach you how to deal with the missing values. Okay, that is the main logic. Comma, I have to assign the values for, let's say, China. The values are 10, 20, 30. Okay, so now if I check my dictionary over here, how it looks like. Let's convert it into a data frame. PD dot data frame, and where my data is my underscore dict. Okay, and the rows headings are over there. I have to give only the columns headings. Let's say the columns headings are state A, state B, state C. So now if I check my data frame, that's, wait a second, I think we missed something. Let's understand it in detail. What just happened? There are no values, right? What am I missing? Okay, I'm sorry. Instead of typing this columns, I have to type index over there. So now if I trigger this, I can get the values. So this index, state A, state B, state C, because these are the column headings, right? And I get this over here. Make sense? So this is over here. So this is the data frame that I have created. Now I can see the null values over there. Understand about the first function. I will type df.drop_na. So what will happen if I trigger this? So it has dropped the null values for me. So you see in this row number second, there is null value. So it has dropped the entire row for me. In state C, the third row, it has dropped the entire row for me. So the point is that by default axis is 0. You see? So if I select axis is 1, let's put over here, axis is equal to 1. So it will drop the column. So India has null values, USA has, and you get the China as your answer. Right? But there is a way through which, you can define your threshold as well. What am I saying is, df, this is your data frame. I'm typing, let's say, df drop na threshold, you will type just thresh is equal to 2. So what does that mean? It means I will see values if there are at least n number of values which are not null. So see, I have not given the axis. So it means by default axis is 0, which is talking about the rows. So in this, there are at least 2 values which are not null because all 3 of them have values. In this, there are at least 2 values which are not null, that is 30 and 20. So I will get this as my answer. But in this third row, I don't have, more at least 2 values which are not null. I have only 1 value which is not null. So this value will be dropped. If I trigger this, you can see state A and state B as your answer. And if I do the same concept in case of columns, put axis is equal to 1. I trigger this and that's it. That's your answer. Sorted? Makes sense. So this is about drop NA. And the last concept, let's understand about the fill NA. So this is drop NA. I want to assign this null values 0. So I will put df.fill NA, and the value I want to assign is, let's say, 0. So you can see that. Make sense? So that is just I wanted to cover. And you want to make it permanent, just put comma in place is equal to true. And that's it. That is your answer. Now you check your data frame. That's how it looks like. Okay. So we have covered in the first phase of Pandas about the series, data frames, and missing data. So I hope you all enjoyed this session, and I will see you in the next one.